We're going to be looking at proportional reasoning, and the method we're going to use to solve this is by graphing. The overall expectation is solve problems involving proportional reasoning, and the specific expectation solve problems requiring the expression of percent, fractions, and decimals in their equivalent forms, and we're going to use some dynamic software to go about doing this. So let's read our inquiry-based question. We'll read it once through and then highlight what we think is important. There are 270 grade 9 students at a high school, and 80% of these students attend the spring dance. Half of the grade 9 students who attend the dance buy their tickets at the door. How many grade 9 students who attend the dance buy their tickets at the door? So this is kind of like a two-part question. Let's highlight our first part. There are 270 grade 9 students, okay, and 80% of these students attend the spring dance. So most of that is important information. Part 2. Half of the grade 9 students who attend the dance buy their tickets at the door. And the question asks us how many grade 9 students who attend the dance buy tickets at the door. Okay, so we have our part 1 and part 2. So we're going to essentially have to set up almost two parts of this question. We said we're going to do this by graphing, and because we're using some software for graphing, we want to build an equation. These are directly proportional relationships, and what we mean by that, if say we have number of students at a school, okay, and our other category is number of students at the dance. For direct variation, if there are 0 students at the school and there are, which would mean there would be 0 students at the dance, that means our graph is going to go through the origin. So say we're graphing, we know our point's going to go through the origin, so it's a direct variation type question. So that means we're going to be using this type of formula. Y is equal to m, which is our rate, times x. Now luckily, they've pretty much given us our rate. We just have to define our variables. In this case, we want y, our independent variable. That's going to be the number of students at the dance, right? That's going to be our, sorry, did I say independent? That's going to be our dependent variable, okay? And our x variable is the number of students at the school. That's our independent. So as the number of students at a school increases or decreases, the same would happen to the number of students at a dance, hence y depending on x. So if that's our case, okay, we know that our y is the number of students attending the dance. Our rate, which is our m, is actually our percentage that they've given us, and x, we said, was the number of students at school. So the percent they gave us was 80%. All we need to do is convert it to either a fraction or a decimal. So let's kind of do that down here. 80%, to convert any percentage into a fraction, we just put it over 100. Okay? And we can reduce that. That fraction does reduce. We can reduce it right down to 4 over 5, actually. And in order to do that, we would have divided both of these by 20. Now, you might not have seen that right off the bat. You might have divided by a few numbers to get to that lowest fraction, but that's fine. And again, to turn it into a decimal, we actually go about dividing this. 4 divided by 5 or 80 divided by 100, which is actually 0.8 if you check on your calculator. So I can write my equation as y is equal to 0.8 x, or we can write our equation y is equal to, let's say, 4 over 5 or 80 over 100. Any of them are acceptable because they're equivalent fractions, times x. Okay, so let's go to our dynamic software and type this in. Get rid of this one to start. Y equals 0.8, okay, and I just want to show you y equals 4 divided by 5 times x gives us the exact same line. You'll see they put a purple line right above where the red line used to be, which is great. What we need to figure out in the question, if you remember, x was representing the number of students at the school, and it turns out there were 270, well, grade 9 students who went to the dance, or at the school. 80% of those went. So because our x represents our students at the school, or grade 9 students at the school, I'm going to put a vertical line, x is equal to 270, and that's going to intersect. Our intersection point is exactly what's important. X representing the number of students at the school, Y representing the number who attend the dance. As we zoom out a little here, you'll see that if 270 students are at the school and we have an 80% rate, both of these representing that, then there are 216 students at the dance. Great, that's important for us. So we know that 216 grade 9s at the dance. Great. Now, that was our part 1. Part 2, same idea. Again, it's directly proportional. If there are 0 students, so number of students, number of students at dance, and number who bought tickets at the door, tickets at the door. If there are no students at the dance, that means none could have bought any at the door, and therefore if we're graphing, we know we're going through the origin. This is direct variation, so which means we're using again this formula y is equal to m times x. Okay, we just have to again set up our independent variables. Well, the number of tickets bought at the door depends on how many students go to the dance, which means x is our number of students at the dance in this case, which it wasn't in our last version. This is our independent variable. And the students who bought tickets at the door is our y. They are our dependent. This depends on how many students actually come to the dance. So y is equal to our rate times x. Okay. And our rate, if you go back into the question and look, they said half. Well, half can be represented in many different ways. We can do 50%, which to turn it into a fraction, right? We do 50 over 100. We already talked about that before. You can reduce that fraction. And if you actually divide both of these by 50, top and the bottom, you get 1 over 2. Okay? If you divide those values, you can turn it into a decimal, which is 0.5. So that's showing a percentage, a fraction, and a decimal all being equivalent. So we can replace our m value with 0.5 or half or 50 over 100. Any are acceptable. So let's again write our two equations. Y, being students who bought tickets at the door, is equal to 0.5 times the number of students at the dance, or y is equal to our rate of 1 over 2 times our x. So let's plug those two equations into our software again. So we know it was 0.5 or 1 over 2. And again, if you notice, we don't need 270 this time. Our two lines are overlapping each other. So those are exact same rates. But there's not 270 this time. In fact, there's only 216 students. So I'm going to put a vertical line at 216 to find out where it intersects. The x value represents the number of students who went to the dance, and the y value, 108, is how many bought tickets at the door. So it turns out 108 students bought tickets at the door. Tickets at the door. Okay. There we go. If you'd like to see other ways to solve this question, you can look at our other playlists dealing with proportional